and then today's going to talk about some of the changes in the software and some of the new cool things we get. We did kind of what the first couple days of build season looks like, kind of how we go from we get the game announcement to how we're going to actually start building a robot, that kind of thing. One of the things we kind of could probably ask, so we have about, 8-ish hours today, plus lunch and things. What are some things that you don't want to leave here without us talking about type things? I know money's on one of them.
Money, yeah.
Yes.
Money, funding, non-robot stuff.
That's actually the top.
Yeah.
Was
We
top
definitely know we're going to talk about money at some point today. Anything specifically that you want to hear about, don't want to leave without hearing about?
Drivetrains.
Drivetrains?
More about the Robo-Rio.
More about the Robo-Rio? Okay, when he does software, a lot of that in there.
So if you can take that little piece of paper that you have and you can, if you want, you can put your name on it, because I'm looking at this thing here and I'm going to get rid of it. I don't want to take it back with me, so if you're interested in it, I'll pull your name out and you can take it.
The whole board?
Yeah, I'm just going to send the whole thing.
Just so that is like an awesome giveaway, just so everyone knows. Those gray Thompson compressors.
Just say your name.
Legitimately, we had the story of the Thompson compressor. Everybody used to get in their kit of parts. You used to get one every single year. Veteran teams have a bunch of them. A lot of them do. Now, if you want to find one, they're about $450 to $500 on eBay.
Those?
Yeah.
Really?
Yeah.
Oh, well, then maybe I can get it.
So we borrowed one from Torque for a while because there's one on our real robot. We borrowed one from Torque for a while, and then we got one because I had a friend in Hawaii who apparently found one and shipped it to me. But yeah, they're not common.
Wow. I'm going to think about that.
Yeah, I was about to say it's a little shocking.
Yeah, I'll put my name in 3 times just to get the price.
Wow. Well, we might still do that. I don't know. And I have a few other assorted items in here, so might share those. And then I have these chassis over here. I'm not taking these chassis back with me, so they're either. I know Alan doesn't want them.
I don't.
Yeah.
Yeah, we have our own.
So he's got his own graveyard. These are all from our Bravo robots. If you want a chassis to kind of see what some sheet metal looks like. That's why I brought them. It's something that kids can kind of look at. As a rookie team, you should not be. I mean, I cannot imagine you would do this. You should not do this.
No.
You should build a kit bot and love it. Okay, because the kit bot is a solid chassis. The kit bot is like the kind of thing that we would have designed 3 years ago or 4 years ago, and that's where we were. So the kit bot that they sell now and that you get in the kit of parts, they do get that, don't they?
Yes.
That's not even part of first choice for a rookie team.
Yeah, no, they have to get it. So actually, do we want to do drivetrains right now, and then we can? Because I think we're waiting on a few more people before we start grades things. I know a couple people are going to get here around 9.
Okay. Yeah, sure.
Okay, so let's talk a little bit about drivetrains, so we can pull some stuff up pretty fast.
I'll come by and pick up those slips of paper.
There it is. Okay.
Question? Yeah, if there's not a question on it, you're not in the mix.
All right. So when Scott says, oh, we have new people.
New people have to go in dance.
So before we get started, let's talk to the new people.
Are we talking to these new people?
Yeah, I think so. Okay.
Who are you? Which team are you with?
It's a rookie team for the upcoming year, the
Tigertronics? Do you have a number yet?
No.
Okay.
Okay. Oh, there's.
Oh,
Okay.
wait.
Oh.
Yeah,
There's
Explosion, then
Bastrop.
What
Then
is Bear Tech, and then Tigertronics.
Okay.
Yes. Well, we talked.
We learned. Okay.
Oh, no.
Okay. Power transmission. All right.
Question/wrap.
Back to.
Well, if you don't have a question, you can. I guess you can just figure. No, you can't figure it. I'll bring you.
All right. So talking about drivetrain. So the way that right. So, okay. So the way that we describe it when I'm talking to my kids and stuff is for most robots, we talked about this a little bit yesterday, when you're going through like what your robot has to do, number one is, unless they start changing how they build games, is move. And the drivetrain is what allows you to move. And for the most part, it is the most important thing on your robot. If nothing else works and your drivetrain works, you can compete. You can often compete at a very high level with just that.
Especially if your drivetrain's on.
Yeah, and especially if your drivers have a lot of practice and you can do, and you can actually play good defense. For the most part of drivetrains, all you need to be able to do that. Let's do this one.
Oh, good.
Okay.
Oh.
Will the PowerPoints be available?
Yeah.
Yeah,
We'll
I'll
talk
make
about
sure all that.
resources. Okay.
Which brings me to a topic real quick, which is how we do that sort of thing. We use Wiki, so we have a team Wiki that we keep all kinds of stuff on. Some of you teams sitting out here, we have a page on our team Wiki. So, and so that Wiki is private. It's just internal use only. It has things like our branding standards. Tells us how to do, like there's information there about how to use an encoder. I mean, periodically, kind of like early in this, before the season starts, we have a lot of people that kind of work on updating the wiki, and they put new information in there and stuff. So we also use it when we have, we do a lot of Skype meetings, and so when we do Skype meetings, me and James taught that, and it would be Rainbear. We're spread out all over the place. And the kids that are part of the leadership team, and the agenda is in the team wiki, and so that's how we can change it and update it, and then we have a record of it, and it's all right there, cataloged, searchable, and all that sort of stuff. And then we use Google Docs all the time.
So we use Google Drive for everything. We don't have a separate wiki.
Yeah, we have all kinds of stuff on Google Drive, and so. Surveys, like whenever we go to a competition, I send out a survey to the kids to find out who wants to go.
Learning to use Google Forms efficiently helps a lot.
Yeah.
Yeah, we do it the same way you signed up for this thing. Like that's the 10-minute thing that we do to make every event happen. But we even do version control on CAD through Google Drive. We do pretty much everything through Google Drive. Okay. So back to drivetrains. So drivetrains are what get you from point A to point B. Also, they determine a large part of the geometry of your robot frame. So that first couple days, figuring out whether you need to be wide, long, what size your robot needs to be, fits into how your drivetrain is going to work. MVP, most valuable part. Anything else on the robot is by far the most important. Again, if you rip the top off robots and they still have a solid drivetrain, they will win events still because of how good their drivetrain are. A lot of robots can do that. Make sure you can build it. That's what we were talking about. You don't want to do something like the sheet metal drives if you don't know how to make a sheet metal robot. It's much easier to use the kitbot. Repairability is a huge factor. If something on your drivetrain breaks, you either need to be able to run with it in that broken state, or you need to be able to fix it basically in a 5-minute timeout between elimination matches. Because you don't want to have to go into an elimination match not having a drivetrain that works.
It's one of the reasons why when you say a West Coast drivetrain, why they're really popular is because the wheels are on the outside of the frame, and you're able to like remove a retaining ring, pull a wheel off, put the wheel back on, replace the retaining ring, and you're ready to run again.
Yeah, if you manage to break a wheel, but depends on where you're
Well, that only happens if you're 118.
Yeah, like I've never.
Sorry.
Yeah.
You know we're talking a couple of years.
Well,
ago.
118 until this year had been making their own wheels for a while, and they finally realized that was kind of silly. They were working really well, except they broke every match.
It's kind of an ongoing. There's a lot of things.
Your wheels are actually really, really important. Nowadays, there's very, very little reason to make your own wheels. There's teams still doing it. There are quite a few teams still machine their own wheels. There's no reason to do it. You can buy basically any type of wheel and have the same performance characteristics as one you're going to make, unless you for some reason need a correct diameter wheel. Yeah, we can pull out tons of wheels from that back.
These are
room.
giveaways.
Yeah, those are all kit wheels. I have a bunch of giveaway kit wheels too if we want.
And these big ones are giveaways, but no one's going to want to use these.
Not in a drivetrain. They're good for other things. But,
Yeah.
Yeah.
We have
So
so many wheels.
the reason you don't want to have big wheels in your drivetrain is you need less reduction on your motors to get to a reasonable speed. So your motors are spinning really, really fast. The drivetrain part of your robot's going to reduce that speed and get you more torque. If you have bigger wheels, you have to reduce the speed of the shaft a lot more because the diameter of the wheel's bigger. We'll go through a bit of that, the physics stuff in a bit, but I don't want to get too much
I'd
into
say
that.
our wheels have just gotten progressively smaller.
Correct. Everybody has. Like, I mean, and part of that is games as well. The last few years, games have basically been flat floors. You don't have to drive over anything. You can have 3-inch wheels if you want. Start having to drive over things, wheels get bigger again. People get silly and put 20-inch wheels.
Don't let the kids talk you into tank treads.
Oh yeah, just in general, there are some no-nos. Tank treads are one of them.
They invariably somebody will say that they think tank treads are a good idea.
It's not a good idea.
It's not.
We ran it one year, it was okay. It was.
There have never been tank treads on Einstein.
Correct. I don't know.
Well, if they've ever been to
I don't know of a tank tread that's ever. Oh, I take that back. There's been tank treads who won regionals, but not since like first. Not since 05 when like
Okay.
first actually starts mattering. 05 is when we went to 3-on-3. Before then, everything was weird.
Also played pneumatic wheels.
That depends on the game again. Like 2012, a lot of teams used them. They
Yeah,
used
we
them.
had pneumatic wheels on 2012.
That's a frame thing. I mean, same with 2010. We had to go over bumps.
That was
and things.
because of the bottom. So we did it.
Okay.
They were just on the ends.
So the big, so the actual inflatable tubes and everything in the tire. Traction is the interface between the ground and the robot, and that's what a lot of teams, that's what you're trying to maximize a lot of times if you're doing things like if you care about pushing other robots. You're trying to figure out how to get the most traction you can to be able to do that. Now, the traction equation is the friction equation, which high school physics tells us is weight times mu, which basically means the reason why tank treads aren't that important is surface area is nowhere in there. For a long time, that was one of the huge popular Chief Delphi debates was whether how big of your wheel contact you had on the ground mattered for pushing force, and it does a little bit because these aren't perfect surfaces. We're not, not ideal. There is some interaction where like the wheel will actually dig into the carpet a bit, so your surface area does matter. It doesn't matter as much as putting a 2-foot-long piece of tank tread down is going to make you that much better, and then trying to turn that and a bunch of other stuff is really difficult. But the material and actually the wheel design, a bunch of more stuff can be changed to get your traction higher. Yeah, please stop me if you have questions. Okay, power. Power is actually determined by the motors in the drivetrain. Very little else. The motors in the drivetrain and the electrical pathway getting to those motors. So obviously, if you were doing something really illegal and used a higher voltage battery, you could get more power with the same motors. But we're all running the same type of battery. But how you get it there and actually what voltage gets to the motor determines how much power you're actually getting to the ground, and how many motors you have on the drivetrain, how efficient the drivetrain is, all that type of thing. So if you have if you have a lot of friction in your drivetrain, it's not built very well, things are not straight anymore, they're all kind of cantilevered and there's a lot of losses somewhere else. None of that power actually gets to the ground and allows you to push other robots, go fast, all that sort of stuff that we want to do with a good drivetrain.
This is something that I don't do the calculations, but I know that the lead design mentor does, and he is trying to maximize that we're operating like in the peak power region for the motor most of the time.
Yeah,
and Alan was talking about pushing, and our strategy kind of used to be we want to be able to push, but for the most part now, we don't want to be able to push. We think if we're making contact with another robot like that we're pushing them, we're not scoring. This is kind of our
Right, and part of that depends on whether you're planning to play a ton of defense or a ton of offense, and that's game-specific stuff, strategy-specific stuff that goes into it. But on occasion, you'll make that trade-off where you don't want to push, and then that one match you need to win, you need to push through, and that doesn't always work. So, drivetrains, for the most part in FRC, until probably this season, weren't power limited. So they had. What am I trying to say here? Is this slide right? Okay, so the goal is to actually be traction limited. They actually are power limited. I don't know why it says not. That's bad. So what I was doing. Okay, back to slides. Okay.
R typically R.
He'll fix it next time.
Yeah, exactly. So that's exactly what I meant to say. Right, so basically R power limited. So if you were to put the robot on the ground and run it into a wall, what ends up happening is the wheels will stop because they have enough traction to where they can't overcome static friction against a wall. And when you do that, that's when you start pulling extremely high current loads and you'll pop your breaker. So that's if you're geared too fast for the amount of motors you have. Nowadays you can put a ton more motors on a drivetrain because of the way the rules have been written. We have a lot more motors that are able to handle high currents and things. And you are starting to get more 6.4 and 6 and 8 sim drivetrains and all things like that. On a 4 sim drive that's geared too fast, like somebody's like, oh, I want to go too fast, they'll able to pretty easily pop their breaker. If you do the math and you figure out that, okay, we are traction limited, when we push up against the wall, we'll spin our tires before we'll actually pop the breaker, then they'll be
pop
okay.
the breaker, then you're going to just be dead.
You're completely disabled. The main breaker on the robot does not reset. If you go over the current limit on that, you'll pop. Well, actually, okay. If you don't go over the current limit, if you manage to pop it, which is it's a heat thing actually.
Okay.
There's curves out there.
It's called a 120 amp breaker. That means it will hold constant 120 amps forever. So you can put 120 amps through it indefinitely and it will not pop. You can put about 500 amps through it for a little under a second and it won't pop. There's a whole curve and everything if you want to get really into the details of the main breaker. Teams have started icing their main breaker with upside down compressed air before a match to actually make it so it takes longer to pop because it's a heat thing. So they've been doing, a lot of people do a lot of things to be able to get just a little bit more current into their drive because that power equation says the more you can actually, more current you can get to the motors, the more power you have, the more you can push, the faster you can accelerate, all that kind of stuff. So there are practical benefits to more motors, and this is from me, who's slightly crazy in the motor side of things. Many people won't take the weight hit, many people won't do other things. It's, in terms of solving problems, adding motors is a really simple way to make your drivetrain robust. If you can design it. If you're buying gearboxes, the kitbot 4 is fine. The kitbot drive is set to the really smart people design it. The default ratios make it to where it's traction limited in the most part unless you're changing wheels too much to where you gain a lot of traction somehow. But by adding motors, you get the motors stay cooler because during normal loads, they're sharing the current loads. They're taking a lot less heat. There's a lot of redundancy. We at one point we ran a whole half day at an event with this robot where 2 out of our 6 motors weren't plugged in and we didn't know. And we'd never had a case where we had to push hard to where we'd actually find out. And then somebody was going through like the midday check and they were like, well, that's not good. And
so, maybe a silly question, are the motors all running into the same like gear train or something?
Yeah.
They all, so...
We'll get to that in just a second.
Okay, sorry.
I mean,
no problem.
Really clear example back there on the table with the boxes is there's a three sim.
So that's a 3 sim.
Two
There's a
sim
3
mini
sim
sim.
drive.
Oh, okay. It has mounting for 3 sim style motors.
Okay,
so
yeah, those are
right. So that's 2 sims and a mini sim. But lately, and we'll talk a little bit about gearbox in a second. There's a lot of motors that can mount to the same interface as what is called the sim motor, the big black coke cam looking motors. We've been running, those motors have been in FRC since 02-ish, maybe 2001. So the whole time I've been in FRC, we've been running those motors. They're called Sims, slight backstory. It's Chippewa Industrial Motor. It's a Chinese motor company. Used to be called Chips for a long time. Used to be called Chippewas. Now if you refer to that, people think you're really old.
I can do that.
Alan, you're old.
Yeah. Reliable, repairable, relevant, and reasonable. So we talked about reliable and repairable a lot. Relevant and reasonable is this drivetrain and the one that Torque had on the robot, the butterfly Texas things were like changing wheels and stuff, are really great for flat fields. They work awesomely. If you put a bump on the field, they make it much harder to do. So they're not very relevant or reasonable. Like you can build a great drivetrain for a certain year that's very bad for a different one because of field obstacles, because of the speed you need to go. I'll briefly mention 2009, which we'll talk a little bit of history is one of the things I want to get to. 2009, they decided we weren't going to play on carpet for the first time in a very, very long time. It was a terrible experience. Drivetrains that year were completely different because we had to basically, we were emulating a lunar surface, so there was like a certain wheel you had to use and a certain surface on the ground, and it was a giant mess.
It was really a lot more like trying to drive on, just driving on ice.
Yeah.
Is what it coefficient of friction of the field was like 0.05.
Yeah, it was really small.
Also, the software, that opens the software engineers like, they do software people have traction.
Yeah, so we had traction.
Yeah. We loved it. That was for acceleration.
All right. So really quick drivetrain types. Two-wheel drive, don't build it. Where you only have your two of your wheels in the back somewhere have being powered, and then you have some sort of casters or something up front that are unpowered. In general, anything that touches the ground should be powered. Yeah, unpowered wheels are robbing you of traction because they're not being powered and some of your weight is going onto that wheel. So anything that actually supports the robot and supports weight needs to be powered in some way. Four-wheel drive, 2 gearboxes. In this design, you have 2 gearboxes up at the top powering the 2 wheels, and then you have chain or belt or some other way to transfer power over a long distance to the front 2 wheels. This can work, but the issue is if you build a long robot in this configuration to where the 2 wheels on the side are farther apart than their width, it's very hard to turn because you're basically trying to what's called scrub your wheels. So as you turn, if you're in a drivetrain like this where forward is this way, when you go to turn, you're dragging these wheels across the ground, and that's really difficult. So there's many ways to get rid of that. The simplest way, and the reason that drivetrains a lot of times have 6 or 8 wheels, well, this is just the same configuration except gearboxes are powering each individual wheel independently. If you do this, the slight problem is when you, in a pushing matches, you'll actually elevate yourself slightly, and you'll normally pull at least one wheel off the ground. If you pull a wheel off the ground in this configuration, whatever wheel's off the ground, that motor is no longer contributing to pushing force, and you lose all of that. You're still spinning the wheel and you're putting power over there, but it's no longer getting to the ground, it's not helping you at all. If they're belted together or chained together, then all the power still goes to whatever wheel's on the ground on that side.
So when we go to like Lone Star and rookie teams have those 4-wheel drive systems, and they're all just wheels like these here. So we try to have some Omni wheels with us because if we switch out a pair of wheels to be Omni wheels, suddenly they can drive much easier.
So I'm gonna ask you to go. So in the back, underneath the table, there's like 3 rows of bins. The middle bins have a bunch of wheels in them. There's Omni wheels, there's a bunch of wheels. Just bring out like the whole bin.
They're kind of like those collector wheels that he has, except the rollers are turned.
They're on the underside
yeah,
of that
they are on the
drivetrain.
underside.
Yeah, like they're our main actual drive wheel. Okay, so this is the default standard drivetrain lately in FRC. This is what the kitbot is. This is what most people, if you're building a standard drivetrain, you're building a 6-wheel drive, 2 gearbox drivetrain, which means you basically power one of the wheels somewhere along it, doesn't really matter which one, and then you chain or belt or gears or some other way to get power to all the wheels on the side, and you have 6 wheels. The most important thing about a 6-wheel drivetrain, most important thing, and when people forget it, it's very sad. These center wheels have to be slightly lower than the front or back wheels. So the front or back wheels are on a plane, or on a line, whatever, and the center wheel has to have a small drop in it. Small being less than 1/8 of an inch most of the time. I think the kit's 1/8. It might be 3/16. I don't know if they might have increased the drop. But for the most part, that kind of depends on how rigid your chassis is and some other things. But the goal is that you're never on 6 wheels at a time. You actually only want 4 of the wheels to be touching the carpet at any one time.
If you do that, remember that the top part of your robot swings back and forth as you rock from the back 4.
That's why the tip is very small.
That's why you have
Jim?
a little bit of drop in the middle.
Yeah, if you're only doing 1/8 of an inch, then
Okay.
that
Yeah,
adds
I'll
up.
have somebody come down and
But,
let you in.
I mean, there is going to be a little bit of rock in there, but it's pretty small.
It's
If you
Jim.
look at this chassis and this chassis, they both have even, like this one is a 8-wheel and this is a 6-wheel. And they both have, like these 2 wheels are lower than these 2. And these 2 wheels are the same height and then this wheel is slightly higher. And that was that way because there was very little weight on this end of the robot. Most of the weight was on the back side of this robot that here.
And that was for bridge stuff the same way a lot of them were, right? Or no, Was that
This was 2013.
Oh, that was your 2013 one.
Yeah.
Okay.
That was just because we went with the 6-wheel,
Right.
but because we were hanging.
Yeah.
We wanted so much weight on the back for that.
You do have to watch your weight distribution on the 6-wheel, simply because if you don't watch it, you'll end up riding on 4 wheels.
Right, which is not bad. It just means you wear those 4 wheels. So
Well, I mean, but you stay there, you
Right.
rock, if you don't have your weight distributed right.
But that's
you
okay.
don't- The point of having the 6-wheel is to be able to turn, you shift a little bit to turn.
not
That's
so.
what we do. That's
Not
what we do.
100%. It doesn't. It's not required that happens. So in 2012, we built a 6-wheel, and we intended to put all of our weight on to where we knew our front wheels would be off the ground 90% of the time. But what that allows you to do is you're shortening your wheelbase so that these 2 wheels are much closer.
But it does help you turn.
Right,
If
so-
if you set it up right, that will help you turn.
No, the whole point of a 6-wheel drive is so you can turn. That's a whole design feature.
Right, but if you put all your weight on one end, you don't turn as fast as if you rock your robot a little bit.
It depends a little bit. So if it's so far that even in accelerations you don't tip forward, which we had our 2012 robot was extremely far back. But the goal is that you're basically making it to where your robot looks like this robot, which now is really wide, and because it's really wide, you have a much longer torque arm, and you're able to turn. Where's my marker go? So in general, the KitBot chassis is set up to where with even 2 motors, it's able to turn reasonably well. Don't put 2 motors in a drivetrain. Please put at least 4 sims. That is one of the things that veteran teams go through in like practice day or whatever at the event. We're checking off people's drivetrains, and if there's not 4 sims on your drivetrain, you're pretty immediately on the not picking for our alliance type thing because you can't play defense well. You will be pushed around the field really easily. You don't accelerate very fast.
Which might be a time to say, you'll see a lot of teams when you get to a regional, and they'll have scouts go out around the pits, and they're all taking down data about the teams, and that's the kind of stuff they're looking for. About the only thing that we look for, and we don't send a bunch of kids out to do it because it doesn't really help. We just watch performance on the field.
We went slightly away from that, but we did it a little bit differently. So we send pit scouts out, and they have lists of questions. They have questions they ask, and they have questions they're not allowed to say, but they're actually writing down data for it, and that's actually more useful. So they're getting things like we went a little farther this year to where we know how many battery chargers teams have, how many batteries they have. So if we're picking them, we know if we have to like supplement their batteries for elims, because you have to play potentially 9 straight matches in an hour-and-a-half period that a lot of people can't do. So we know all of that going in, and we'll ask about batteries and stuff, but we even judge. We have little 1 to 10 rankings on how clean your pit is, how organized it looks, what your cart looks like. We're doing a little bit of everything, and all of that goes into our scouting meeting the night before of whether the team's going to be reliable enough to run through eliminations with, because it's literally 9 straight matches possibly, and they have to be ready to be able to make repairs and all of that kind of stuff. So yeah, we'll look at pretty much everything when we go into.
But that's, I'm looking
scouting
at,
stuff.
like when I come around, if you see me, I'll walk around, I'll have this with me, and I'll be like this with my pen. And so I'll be jotting down things, and I'm jotting down types of wheels. You already mentioned the number of motors on your drivetrain, kind of like in 2012, the size of the robot and the orientation of the robot made a difference, not so much in the previous 2 years.
Yeah, so
But those kind of things to help with match strategy.
Yep.
Because that's all I'm really looking at, because the down the road picking people has to do with performance.
Yeah, we can know whether we're like scared of you on defense, whether we're not sure if we can either push around you or accelerate faster than you, of all that kind of stuff, and we'll get that pretty well.
By the
We
way,
try
for
to do-
2789, we are scared of you on defense. You know what I'm talking about.
Yes.
Do y'all ever try like different sides in the 6-wheel model, like smaller wheels in front and back and larger wheels in the middle? Or are the wheels always the same size?
No, that actually works. 118 ran that for a while. You can get away with it. So the only issue is either you change your gear ratio or one wheel's slightly slipping more because it has a different diameter, right? So if they're all spinning at the same revolution or RPM and they have slightly different diameters, then they're not covering the same distance per revolution. So if you get too far off, you get a problem. But if you need to build it along one axis and change wheel diameter, you can do it. 118 did it for a long time with roughly 3.5-inch wheels and 3.25-inch wheels, something around there.
So that's an
That is an Omni Wheel. That is a giant 8-inch. Don't put on your drivetrain Omni Wheel.
It looks like you're putting in your pool.
We have like 4 of these.
Yeah, I gave away a bunch of those at different times. That can definitely be given away. Yeah. I know that those were running on our 2011 robot, I think. But yeah, so the small rollers allow you basically to completely eliminate scrub from the robot. So all that we're talking about when you're dragging the wheels across the ground is eliminated with Omni Wheels because you have no scrub.
The majority of the time this past year, our robot was on 4 Omni Wheels,
correct.
and they were like 4-inch.
4-inch, yeah.
Diameter.
Yeah, we run.
I don't know these things.
Most of the time on 4-inch diameter Vex Pro Omni Wheels as well. Yeah, we'll talk about sources and go over quite a bit of Vex Pro stuff. Because Vex Pro, for people who are brand new, Vex Pro literally just really existed for the last 2 years, and they changed a lot. So they have been, Andy Mark is a really reliable vendor. They've been great for a long time. But Vex Pro came in and introduced a brand new product line with a bunch of stuff designed by people who've been doing high-performance FRC robots for a very, very long time. But they basically started hiring first kids out of college, a bunch of them. James Tompat is actually one of their mentors, is up there now. And then several other people who are designing really great stuff for them.
One of the questions here is about how do you like get and identify and engage sponsors. So James, when he signed his contract with IFI, Dex people, part of his negotiation was that they would sponsor us. So that's one way, is have one of your people hired by IFI.
Just really quick on the combinations. Just making sure I understand. You don't talk about more than 2 gearboxes. That pretty much been eliminated as too much extra weight, complexity.
You could definitely do it. It just depends on what you need to be able to do. So, like that robot technically has 4 gearboxes, but they're really, really simple. So there's a single pinion gear, which is like the main gear on the motor, going into a single gear that then drives the wheel. And there's 4 of those, but for complexity and weight and reasons, that's reasonable. But if you were to do multiple shifting gearboxes, and there's teams that do it, I think Secret City Wildbots from somewhere over in Tennessee, Kentucky area, I don't remember where, they had 8 motors with all shifting gearboxes, and it was ridiculous. But not everybody will be doing things like that.
But as far as the standard goes, it's typically
the standard is
in-wheel drive with 2 gearboxes. You can get multiple simple gearboxes.
Right, and yeah, you get, there's numerous off-the-shelf gearboxes you can buy that'll take 2 or 3 motors now in each one. So then you have 4 or 6 sims or whatever on your drivetrain.
You're only like 1 or 2 choices.
And then you belt or chain to the front and back wheels, or to the 2 front wheels, depending on where you put your gearboxes, whatever you're doing. So all of these drives that we've talked about fall into the category of tank drive, basically is what people call it. They drive actually like a skid steer tractor or like construction equipment, all of that. You turn by driving one side forward and the other side reverse, or stopping this side and driving it forward, and you can arc. All right. So this goes into some more like technical details. You're trying to remove friction everywhere in your drive. The more efficient it is, the better it's going to be. So ball bearings, that kind of thing. Proper alignment's important. Press fits in drives normally don't work out very well. You need some way to actually transfer torque. That's a picture of an actual keyed shaft. So you have a keyway, you have a keyway and a key seat, and there's a small key that actually goes in, so you actually have a piece of metal that's actually transferring the torque. This is still used by several times. You'll use this on all your pinion gears on your sims, but a lot of teams have been moving to hex shaft, which is basically instead of a round shaft, you have an actual hexagonal shaft that transfers torque through the faces of the actual shaft. And that's just a lot easier to use because you don't have to deal with actually getting the key in there and making sure the key doesn't fall out and a bunch of other things. And there's enough vendors now that sell hex products that you can do it that way. This one is important. So supporting your shafts in 2 places. So this looks like what most people would call a West Coast, except if you only had the shaft supported on a single bearing here, it would be bad. So the secret to West Coast is they're actually doing it inside of a tube, and they have 2 bearings in it, but it looks like they're only supporting it in one place, but they're not. If you actually only support it in one place, it'll wobble and do all sorts of weird stuff. If you support it in more than 2 places, you can very easily get them out of alignment, and that is bad. So a shaft with 3 bearings on it and a rigid configuration will not be good. Cantilevering too far is bad. The reason West Coast can work is the wheel's tucked up really close to that bearing. By cantilevering, again, a lot of this stuff comes down to basic physics. The longer the torque arm is, you're putting a bunch more force on the chassis. You're going to get deflection, all sorts of problems like that. Again, misalignment is bad. Yeah, I really like PowerPoint drawings. Okay, so I don't have sketches for all of these because for the most part, young teams shouldn't be doing them. This is old enough where I don't have text drive on here. I can do back when they were still calling it Nano Drive. So you can do various forms of omnidirectional drive, which basically allow you to drive sideways. Depending on whose philosophy you're using, that's either awesome and really important if your team's like 16 who have been world championship, or it's the silliest thing in the world if your team's like Cheesy Poofs who have won world championships. So it kind of depends. But they do take a lot of time, and the cost of actually doing the time and money and resources put in a first-year team or a young team normally isn't worth it. Was this your first year trying to drive sideways, or was ours? Or ours on the spectrum?
With something other than
Oh, you had mechanism before, right?
collector wheel.
Yeah, collector wheel. Yeah.
Yeah.
Okay.
We looked at the beginning of the season. One of the things that we talked about is because the robot was, we thought the robot was going to be fairly simple. Was, well, maybe this is a good year for us to try like unicorn drive, we call it, where each one of the modules is controlled independently, and so you can do anything you want with the orientation of the wheels. So the wheel orientation is controlled by a motor, and then the power to the motor also. So basically, it's 8 motors for the.
Yeah. So this is
There it is.
No, this isn't actually quite unicorn. This is just swerve. So each module is actually steered together. So in this case, you actually can't turn.
Right.
Because they're all powered by the same motor, so their forward and back is all the same, and they steer independently. So it lets them drive basically like this, but they can't actually rotate.
What year is that one from?
That's a Team 221 Systems, Anthony Lapp's company.
Oh.
But it's based off the Revolution module, which was from 118
2000.
back in the 06 range.
Yeah.
They started it like.
Well, that's what when I saw the.
Yeah.
That's what I was thinking.
Okay, back a bit. All right. So Holonomic XDrive, this is used pretty sparingly in FRC, but you'll see it in FTC and Vex a lot more. Basically, you have those same type of Omni Wheels put on 45 degrees on the corners of a square. And depending on how you drive, you're doing vector addition. So when you drive these 2 wheels in on each other at 45 and the other ones out on each other at 45, their sideways stuff gets negated and you drive forward. You need a lot of controls and stuff. This is actually the CAD from the 2011 Disco Bots robot. Actually worked relatively well due to a lot of gyro software stuff and getting field-oriented controls. So where if the driver put the joystick forward, no matter which way the robot was actually oriented on the field, it always drove away from him. When they rotated it, it would rotate. So that works out, but it took a lot of time and a lot of time in the lab till like 4 a.m. coding stuff. So I didn't get a lot of sleep at the end of that build season.
Field-centric is
Yeah.
what we call that. When the joystick is tied to the position, to the field instead of to the robot.
It has a lot of issues. Basically, it can be pushed around the field all day. So if you ever want to push anybody, don't build that, because when you actually do the vector math, you're reducing torque, or you're reducing pushing force a lot in every direction. It actually does something really weird if you start looking into the scholarly papers. The robot can move faster than any one individual wheel is turning because of the way the vectors add up. You'll get actually 1 square root of 2 the drive, so it's actually, or square root of 2 the speed of the drive, so you can actually get a really fast robot, but you end up with inefficiency of a bunch of other stuff. HDrive is basically the 4 Omni wheels in a normal tank drive configuration, and then you have some Omni wheel perpendicular to them in the middle. At one point, Torque was running a drive with that.
That's what these were for.
So they had 2 different wheels cut out in there perpendicular to drive, so they literally had their normal drivetrain driving all they wanted, and then they had 2 sideway wheels that they could power and go sideways, so they go straight.
These here were where the Omni wheels were. So Omni, 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 Omni. And so we could be pushed sideways, which we weren't as concerned about being pushed sideways as being able to move sideways to get out of the situation.
Right.
So,
Did you guys have a piston that would pull up the wheels, or did you leave the wheels down on the center all the time?
some people would, who did that? I think
Different
624 left theirs down all the time.
They did until TRI.
Yeah.
They fixed it at TRI.
They did, they fixed it, but ours were up and then they would go down. When we pulled those modules out, which we did after Dallas, we took them out, and the robot, we gained 10 pounds, or gained 10 pounds of extra weight to use.
A lot of people, like, I mean, when I saw that them and Kryptonite had it, I made a bet with my kids figuring out who would be the first one to get rid of it. As we realized pretty quickly in this game that going sideways wasn't that necessary. Kryptonite reused it a lot though. I mean, their 2-ball relied on it, so
Yeah,
they
their
got
autonomous
right.
uses
So they made
sideways.
it really beneficial for them. So if you can do it and you do it well, it works. 148 has a really cool design this year that they don't have pneumatics at all. They actually just use the motor torque to rotate 2 different wheels down. It's actually really awesome. One of the more clever things I've seen in FRC robot in a very long time. It needs a lot of motors. It's heavy. It's relatively easy to build compared to the other ones. You don't have to sacrifice nearly as much if you want to go sideways, but it does take up a lot of space. Those things, some people swear by them. There are teams who build mechanism wheel robots every single year. Good for them. I will never do it again. I recommend you don't.
We were amazed when we talked at the beginning of this season about trying the mechanism wheels, and then because James, the other design mentor, he hates them with a passion.
Yeah, no, and I was on board with the hating them for a long time too.
And then he actually kind of, when we were talking about it, we were afraid to suggest it. He kind of he said it.
Yeah.
And it was like, what?
Yeah.
So we tried to cover it up.
Literally the same thing happened on our team as happened on their team.
Well, one thing to remember though, with those in absolute, whether you like them or dislike them, is that for non-flat surfaces, they're distinctly not good.
Correct. Yes.
Well,
But
yeah,
for flat
another
surfaces,
thing
they can work.
is like on this system, you don't want your chassis to be real rigid. It's better if it's a little bit flexible, because then that means that you get good contact with all the wheels, and the weight distribution is important. Because if you have like a bunch of weight on the back of the robot, then those wheels are going to move. They'll have more traction, and so your robot it'll go like this as you go sideways.
We made that mistake in 2010 when the soccer game, and trying to climb with them up was just a big fail.
Okay.
It just
Awesome.
didn't
Kind of
work
made
out.
it work out, because we had something we called it orbiting. We had the ball in front of us in 2010, so our robot could do what I was just showing, and the ball was basically the pivot point. We didn't set out to do that, but it turned out that way, and so it's kind of like, hey, let's work with that a little bit. That was a bad year.
So a couple things so with these, you do have to have 4 gearboxes, because you have to independently control each wheel. Because the way it works to actually go sideways is you're driving these 2 wheels in on each other, these 2 wheels out on each other, and then you get a vector going that way. So it's a little bit weird. They do odd things. That's why we use them on our collector there, because you actually get a 45-degree vector. So when this point contacts the ball at all, it brings the ball immediately this way. So it drives it hard against our front bumper and in. So we can collect from actually this point, and it'll actually hit here and then pull in. So we're actually using what normally is on a drivetrain to get that vector to actually move the ball into where we want it to go. You do have the same problem with if you had this configuration, except just with like normal wheels. If you're in a pushing match or you get hit, a lot of times 1 or 2 wheels will come off the ground as you basically ride up somebody else's bumper, and you lose all of that motor power on the ground because it's not being chained or driven back to your other wheels. We actually have that problem on this year's robot because we didn't chain or gear our modules together. I don't think they did this year either. But 148, who built similar robots, they did belt theirs together, so they get a little bit more pushing better that way. We talked about crab swerve. This is the most complex drivetrain you can build. Most teams who had been building it for historically a long time have gone away from it. There's still a few. Bomb Squad still builds it every year. 1717 for the most part builds it every year. But there aren't as many anymore. Or some of the more notable ones. Wild Stang, who used to build it, I don't think they did this year. I know they did last year. Tank treads. Yay, we've gone over that. Really heavy. This at one point was called Nano Drive. Now it gets called Butterfly or Tex Coast or something along those lines. And basically you're shifting between an Omni Wheel drivetrain and a traction drivetrain. Because what it allows you to do is it allows you to change the gearing to with like how fast or how slow your robot's going in terms of top speed, while also changing your traction equation. So by changing the different types of wheels in here, this is hard to see, but there's the modules. You basically have an Omni wheel and a traction wheel. The Omni wheel is geared faster, so you're going much faster. Yeah, well, if you want to look at it, that robot and the chassis for that one does the same thing. And we'll have, yeah, they'll bring their robot as well.
So where's the ninth wheel in there?
Oh, so this one, the picture's not there, but there's a ninth wheel that's here that pushes up and down. So that allows it basically to be an HDrive or a normal tank drive at the same time. And at some point, oh, not on my computer, but I can pull up the CAD for that robot too. One of the good ways to go through and learn about robots is to get either SolidWorks or Inventor a CAD package, a computer-aided design package. A lot of teams release the CAD for all of their robots. So 148 has all of their robots up to, I think 12 are up online now. I think you can get 12. I don't think you can get 13 or 14 yet. 118 releases most of their CAD files. 1114 has all of theirs now, which they just did this summer, which was awesome.
You said 11, 14.
Yeah, and they've won a world title. They build awesome robots every year. But you can go through and dissect people's CAD models and learn exactly how they build things, because it's all right there. Especially all the teams who do sheet metal design, they have to CAD every bit of their robot anyway. So they release all the CAD.
Most of ours are up.
Yeah, I think all of ours. I don't think that one's up yet. And last year was only like whatever we CAD'd, which was like half of it. Okay, so this is Octacanum, which is the same idea as before, except now you're switching between mechanism wheels and traction wheels. This is what Torque and I both, and Spectrum both tried to do at the beginning of the build season, and then quickly decided we didn't want to do anymore. This current picture is one built by Team 488 XBot out of Seattle area. They actually built a version of that this year as well, and they seem to do okay with it. Okay. Now, briefly, as quickly as I possibly can, we're going to try to do. Really? Okay. Stop.
You put it in RR.
Yeah, oh, thank you. Okay. Gearboxes and power transmission. All right. So, really quick introduction to how gears work. Okay. Speed, torque, and power is what we're basically talking about when we're doing gearing stuff. Speed is how fast something is going, torque is your rotational force, and power is torque times speed. So like I've already said, motors provide the power, and motor spec sheets are really important to tell you what the actual free speed is. So if you just turn it on at 12 volts, how fast is that motor supposed to spin? They're all within a range. They can be, as long as they're close, you can put them on the same drivetrain and you'll figure out, they'll work together. DC motors are pretty forgiving about that. The mini sims actually spin at about close to 1,000 RPM off of each other, but you can still plug them in next to each other and they work. In general, down there you can see sims spin roughly 5,500 RPM. 5310 is the actual spec sheet number, but that varies from motor to motor. At one point, there was a team who was actually like built a dyno and was like clocking them to try to get, I don't know, faster ones or something. I'm not entirely sure what they were doing. For the most part, it doesn't matter. The difference in speed is not a couple RPM here or there. Isn't going to change much. Okay, so this is the actual motor table. So we get one of these every year. Is this? No, this is an old one. So this doesn't have the new Bex motors and stuff on it yet. But they give one of these every year in the kit of parts that basically describes every motor that's available in the kit. You can go through and find out what its max power output is, how many watts. The reason we use sims on a drivetrain is they're about 340 watts. Other motors that we can still use, Bainbot's RS775, those are the motors that we have in our collector, are 275 watts. So you can go through and what? No, that's the 12 volt spec.
Oh, it is?
Yes.
Okay.
It's an 18 volt motor at 12 volts, 275 watts.
When you look at the 775 and you compare it to a sim, you're kind of surprised that they're that close to each other.
Right, like motor size doesn't necessarily transfer to power wattage at all. You have to look at the spec sheet because there's actually the Andy Mark and Banebots both sell a motor that are the same body type. They're both 775 body types, which are standard motor types used in RC cars and used in a bunch of other places. There's 550 body types, there's 775 body types. One of them is 275 watts, the other is 48. So body type and size do not correlate to motor power at all. It's entirely what they're able to do inside the windings, the commutator, and a bunch of other motor stuff that we don't need to go into.
Size-wise, they look identical.
They look entirely identical to the point where I've told inspectors this team's doing something illegal, they have the wrong motor types, and they've gone, no they don't. And I've been like, oh my god, okay.
Yeah,
I'm not going to argue right now, but it's labeled and they're wrong. So yeah, you actually have to look and see the actual model number sometimes on the motor, but yeah, they'll look identical. But sometimes they'll have slightly different shaft outputs and things, but they'll be generating drastically different power. You also get free speed, which is, like I said, how fast it's supposed to spin when you just apply motor voltage to it. The Banebots motors are spinning very, very fast. You're getting 19,000 and 13,000 RPM out of the ones that have power outputs you want to use, which are the 550s and the 775s. So you need to do a lot of reduction to get that down to a usable speed. Why does that slide make noise? All right. So how do you get power from the motor to the arm, wheel, whatever? And that's in some way, that's where we're talking about gearboxes and power transmission. So gears, roller chain, and sprockets, and belts are the common ways to do it. For a while, it was a lot harder to do belts because there wasn't a specific COTS vendor. Vexpro, just this last season, released a line of belts that work well in different ratios and things. The KitBot now is a belt-driven one from Handy Mark, but your pulley size is all determined for you. They only sell a certain pulley size. That's one of the issues with belts, but we can go to that in just a bit.
A good supplier for belts that we've used is Royal Supply. Royal Supply carries almost the entire Gates line of pulleys and belts.
But to do the pulleys, you have to machine the bores, don't you?
But I can buy belts.
Right, you can buy belts, but you have to machine the bores, right? So that's a lot harder for a lot of teams.
Well, all I'm saying is they have the pulleys. We've actually never bought them.
Oh.
We even have machine capability. We buy standard pulleys from any marker backs wherever we can find them with the right insides.
I got you.
Okay, but then if you need a belt that stretches this far and you can't get one out of the kit of parts, World Supply has things. Don't count on them delivering it in 2 days. So be reasonable in your expectations when they're going to deliver. I waited as long as like a week and a half for things. So we have a stock of belts that we bought over the time.
Okay, so we'll talk a little bit more belts in just a second. Okay, so gears are the basic way you're going to do this. Gear teeth, basically, you have. It's not going to draw.
No.
Oh,
Go on. Yeah, I might, but it won't be. No.
Okay.
Yeah, I am drawing.
Gearing is the most frequent moves. Almost the first reduction is often a gear because you have some pinion gear on the motor that goes to some other gear, and then you use a belt or a chain to basically transfer the power over a distance. That's not always true. A lot of teams will use, depending on if they only need a small reduction, they'll use a small pulley on the motor to a bigger pulley on whatever it is. Cheesy Poops did that this year on their shooter. They're able to do a little belt tensioning, and they run a little quieter than gears and things like that. Spacing isn't necessarily as important as you don't have like the gears actually meshing. You don't get the friction and wear and things you do from a gear. So they're very, very efficient, especially spur gears. There's several other different gearing options. If you look at the gearboxes that Seth brought in the back, they have miter gears and worm gears and all sorts of cool stuff. Most FRC robots don't. Most FRC robots are entirely just spur gears where the gears are in plane to each other and they're meshing like you would a normal, what you think of a gear, the little clip art image of a gear.
You didn't go through and make those gears in PowerPoint by hand?
I didn't that one. I did clipboard that one. Gear math is pretty easy. Gear math, belt math, all the reduction math is all just ratios. So for that robot, the motor gear or the pinion gear is 12 teeth. The driven gear coming off of it is 72 teeth. So it's 1 to 6. So the shaft that the wheel is on is spinning 6 times slower than the motor shaft. So you can do that with belts, gears, whatever it is. For belts or for belts and gears, it's whatever the pulley or sprocket teeth count is. For gears, it's whatever the tooth count is there. When you combine them, you just multiply the ratios. So if you have a gearbox that has a first stage that's 1 to 3, and then a second stage is 1 to 2, you eventually get 1 to 6 out of it as well.
If you're buying Andy Mark gearboxes or anybody else's gearbox, sometimes they change the pinion gear for your sim motor from model to model. Make
Correct.
sure if that particular model needs a 14 tooth, that you actually use a 14 tooth on your robot, because if you use a 12 tooth, things aren't going to end well.
If you use a 12, does the gear centers even meet? They shouldn't.
Well, you're going to be too far apart.
Right, they don't meet at all.
Either, well, if they touch, you'll be breaking teeth. If they touch.
Yeah, they shouldn't touch, but you shouldn't do
Well,
it because it's obviously not going to work. But
all I'm saying is, make
yes.
sure you know what pinion gear goes with the gearbox, and make sure you have those laying around.
Absolutely. In general, most of them nowadays, some of the AnyMark ones do still run 14. It's a slightly, the reason that teams use 12 for the most part is the pilot on the sim motor. Oh, where's my nearest sim motor? Okay, I don't have one on me right now. There's a small little dimple that fits into all the gearboxes. The 12 tooth gear is smaller than that dimple, so you can put it on very easily and use the actual piloting feature of the motor, which basically keeps it in alignment. When we say piloting, it keeps it straight in the actual hole it's supposed to be in. If you use the 14 tooth, you can't use that without putting the gear on after you put it on the plate to actually keep it centered. So you're relying just on like the bolts to keep yourself in center.
The pinion gear is just the first gear that attaches
To the motor, right. Yeah, so it's normally on the Sims, you actually have a small little key, so you have a small piece of metal that fits in, and you're putting that on and you're retaining that in some way. On a lot of the smaller motors, it's a press fit, so you actually have to use an arbor press or some sort of tool to press it down. Hammer and a piece of plywood or something works as well, just not as well, and can break the motor on occasion.
A Harbor Freight arbor press for about $90 or even less.
Yeah,
That's really good job.
ours is like 60, I think.
No, whatever it
But yeah,
was.
we use the same one.
They've always got like 20%.
Right, yeah, never, well, we'll talk about sources at some point. Never buy anything full price from Harbor Freight.
Well, and don't buy a lot of stuff from Harbor Freight.
It depends on how stuff walks away, but we'll talk about sources later. And buy certain things from Harbor Freight, they work really well. Other things, not so much. There's review sites and things as well. Gear pitch is also important. For the most part in FRC, you don't have to worry about it. Almost all the standard spur gears are all 20 diametric pitch, which is fine. And we use it, but that's basically the distance between the tooth count. You could, in theory, you could make a certain diameter gear and put 1,000,000 teeth around it if they were really, really tiny. So you do have to standardize on that, and somehow most of First use the same one. Not something you really have to worry about. But no, you can't just, if you randomly find a gear that wasn't from a First supplier, it's probably not going to be the same pitch that we use. Gearboxes. So this is an exploded view of an old kit apart stuff box. This is basically the first step in power transmission, especially for your drivetrain. You're gonna have some pretty big gearbox. You need to have a lot of reduction to actually get to your motor shaft. So you have your motors here. These are your two sim motors. They are gonna actually power right here. Are the little pinion gears that power them, and they power another gear here. It's on the same shaft as a small gear. It has another reduction, so there's actually two different gear sets in there. And then that powers the output shaft here that eventually goes to a belt or chain and powers all the wheels. Here's it basically assembled. So you have the pinion gear which locks on, two other gears that share a shaft, so these are spinning at the same rotation speed. Then that gear powers that one, and you have the output shaft. Again, when you're doing the math for that, you're multiplying those two. I think that's actually the 14 tooth pinion in that picture, I believe. So that's 14 to like 48 and 14 to 48, whatever that math comes out to. Shifting gearboxes. Give me 1 second. Scott, if there's anything on gearboxes you want to talk about?
Well, yeah, actually there is. So, like on our robot this year, we don't shift, except we have traction wheels and we have the Omni Wheels, and they're geared differently. So the traction wheels are really slow for pushing, which we hardly ever used, and then we have the Omni Wheels, which are for speed. And our drivers will practice things spinning around. And so I was thinking about, like multi-speed gearboxes and what I would kind of like tell rookie teams about them. And I don't think like your first year out that you would worry about a gearbox, because we spend 95, probably 95% of our time or more just on our high, even when we have shifting gearbox, we spend 95% of our time at 1 gear ratio. So for us, there are times when that other gear ratio makes a difference. We're in a position, like when we shot this year, that's when we would use our traction wheels. We would get in position, we put down our traction wheels, and that's when we would take our shot, because otherwise somebody could bump us and turn us and so forth. But it's a lot of work. It's not too bad to add an off-the-shelf gearbox, but there's the cost associated with it. And for us, we have to have, there'd be 2 on the robot, and then there would be, in our case, there would be 2 on the practice bot, and then maybe 1 or 2 spares. So we wouldn't be thinking, okay, we gotta buy 2 gearboxes. We'd be thinking, we have to buy 6 gearboxes. What we'd probably do is buy 2, see if that's what we want, and then we would buy the spares if that's what we decided to go with.
It used to be really, really hard to shift gears in FRC. You had to do all your own machining, you had to buy a bunch of your own stuff. It took basically the whole build season for a lot of teams to do it. For a little while there, teams were using DeWalt drill gearboxes to shift, because they have their shift in actually a planetary gearbox, we'll get to in a second. But now there's several different COTS options. Andy Mark sells ones that use a dog to shift. That's what this one's talking about. So basically you have this little piece of metal that's riding on a shaft, and it engages into this gear or into the other gear, and you can actually change what ratio is going to the wheels. So you have one, basically, just like in your car, you have different gears that you're driving in. You have one that's geared lower, so you accelerate faster, and you have a much shorter top end speed. That normally means you can push a lot harder. And then you have a higher high end speed where you can actually drive a lot faster, but your acceleration is going to be slower.
Okay, so the 2 faces are in, the dog is in between,
correct.
Going here or here.
Yep.
Use a solenoid pump.
Yep, use a solenoid there's a special shaft that has a inner shaft inside of it that you're moving the dog back and forth on. This is actually the same thing here. This is actually, it's much harder to see. These are VexPro ball shifters. So instead of having the dog, they have 2 gears that have cutouts for ball bearings. And they actually have, I think he has the shifting shaft back there. Or a custom shifting shaft back there.
It's going to hand you this so you can show that.
Yeah, and this can be passed around too.
I haven't seen mine.
Okay. So
I hear him talk about ball shifters all the time.
So this little shaft right here is inside of this bigger shaft that has the gears on it, and there's 6 ball bearings that are actually put on this shaft. When you move it into a certain location, those ball bearings actually push out and engage the gear. And then when you shift it back to the other one, it'll engage the other gear. And if you actually have the right pneumatic cylinder, you can have neutral too and engage neither of the gears, and then your wheels will free spin. Some teams like having a neutral in any of their shifting gearboxes, and they can push the robot nicely without actually turning the wheels in reverse and backfeeding them and some other stuff. So we can pass that guy around.
Which is more reliable, the dog gear or ball shifter?
Depends on the year.
Depends on, some of it depends on the year. Ball shifting, it's not a new technology. Teams have been making their own for a long time. The first one I think I've heard about was in like 2004. But they haven't been commercially available until the last 2 years. So VexPro just released this standard 2-sim ball shifter in 2013. The 2014 version, they have this one still, and they have one that takes 3 sims into it as well. This was really nice. When we bought these were basically $150 shipped, complete with pneumatic cylinder and everything. VexPro has since raised the prices, which is reasonable because they have to like make money still. And the 3-sim one, you're spending $300-something to get just one side of your drivetrain. I've never actually, none of the robots I've ever worked with in the 12 years I've been doing it have ever shifted in competition. This is the only one that ever has, and we do that by shifting the actual wheels, not by having a shifting gearbox. Mostly for the same reason that Scott says, a $300 investment or $600 for the robot once is fine. You know, $1,800, $2,400 when you buy spares and practice robots, not so fine. So if you can custom make them yourself, or if you really think they're an investment, I mean, there's no reason you couldn't put them on and pull them off your robot and put them back on a competition, but doing that to your drivetrain is really, really scary. And I would not recommend doing that too often.
Can you go back that one slide for a second? So when I said depends on the year, this dog gear here, this used to be a pin inside the dog gear, and they switched it out to be a screw one year, and these were breaking all the time. And so that's why I was saying about the depends on the year. So they've since fixed that.
Right, and every year there's some part that teams are widely using and ends up being widely, ends up breaking in some way that it probably shouldn't, but it happens. There have been motors that were shipped where they were case shorting constantly and were breaking everything. There have been gearboxes that the shaft pulls out of. There's been all sorts of different malfunctions.
Cables that were switched.
Oh, that was the really scary one was when the battery cables were switched. Yeah. That was bad. Yeah, so check your battery cables. Little Anderson red things have a plus and minus. Make sure the red wire's in the plus, because that can be bad things.
Yeah, this year they're using the screw version of those that dog gear. We had that for a shooter, and it worked well. There was I don't remember now, but there was some weird thing we had with that bolt. It was a unique link or something, and the bolt we used at first back drove, it fell out, and then we got the proper length, and I was happy with that. I don't remember what the details were, but there was something with that bolt at first.
We just got to the point on our robot, that was the 2012 robot, and we were just replacing those after so many cycles, so many matches that we had played. We never did really do a good cycle analysis to figure out when we needed to do it.
Just want to add a comment. I'm from a team that for the last, 15 years built gearboxes. Most of the time they're 2-speed. You save no money building a gearbox. You save no time. Your performance advantage is very little now because you can buy good gearboxes. You couldn't on that one. The only reason we build them is our students want to build them. Don't do it. And 1 speed is better for almost everything.
Yeah, especially now that you can basically put as many motors on a drivetrain as you want and save costs. So, like, the reason we built that drivetrain is because the entire thing, Sheet Metal's donated to us, which is really nice, but the entire thing was $530 or something like that. Wheels, power transmission, everything, which is less than just 2 of the gearboxes that we would have bought, not counting wheels or anything else.
Does anyone still use the DeWalt thing?
People use them on different things. So like 118 shooter this year was pulled back by a DeWalt gearbox. I haven't seen too many on drivetrains lately.
624 used it for a long time.
Yeah.
When I was with 118, we used those for the drivetrain for many years in a row, and you couldn't break them.
Nope.
I mean, I will always try to buy the DeWalt drill now because
yeah, that was one of my. That was a really fun project. I worked on that project in high school because it was Dr. Joe Johnson developed it in Michigan, but then one of my mentors on the team, we wrote the white paper for it. So that was actually pretty cool. It's difficult to do though. To use the drill gearbox, you have to machine this one pinion that's not designed for it. This one of the input gear, and to do it easily, you have to have a wire EDM machine, which is a ridiculously expensive thing that cuts with. I describe it to my kids as cutting with lightning, because it cuts with a really really sharp amount of electricity. Okay, power transmission, chain. Number 35 for a long time was the most common chain used in FRC. It looks like bicycle chain, but it's not. Don't use bicycle chain. Well, get the back. Hawaiian kids use bicycle chain for a long time, but don't use bicycle chain. But not Hawaiian kids. Somebody in Hawaii, because they just couldn't get stuff. Do they still use bicycle chain? Okay. Because they could just get it in Hawaii. But for the most part, all the FRC spec stuff is either number 35 or number 25. VexPro, AndyMark all sell it. You can get stuff on eBay. You can get stuff from Tractor Supply if there's one out near you. Inner Houston, there aren't Tractor Supplies, which is really annoying. Yeah, Katie has them, but you can't get it anywhere inside the Beltway. So basically, you're able to transmit power over a distance. So normally the last stage before the wheel, just because chaining and then having a geared train would be a little strange. Sprocket teeth are just like gear teeth. All the math is the same. It doesn't reverse the direction, which is useful. So when you have 2 gears together, they're in a reverse direction. Chain and pulleys are all the same direction. literally just like on a bike, except I've never seen a team use this same type of shifting mechanism used on a bike, because for the most part that derailleur requires you only to be able to go in one direction. Reverse on a bike doesn't normally work too well. Alright, pulleys and belts.
Do you have any good ideas for tensioning the chain?
Yes and no. All of that depends on how you build your chassis. So the West Coast style drivetrains that people build now, they have nice little cam tensioner things, so you can build, you can have it, and then you can actually literally move your wheel out. You have about a 1/2 inch to 3/4 of an inch ability to move your wheel in and out, just to be able to change tension. The last robot we built that had chain was awful, and we had these bunch of little standoffs that we could move the chain tension that took forever to tension and get right. One year we just built it dead spaced and pulled the chain really tight and made it work. You'll get inefficiencies, so a lot of it depends on how efficient you want it to be. Those ones have moving, so they're sliding rails. Yeah.
One of the simplest chain tensioners I saw was set on a board to put a larger sprocket inside the chain, spread it out, and as the chain moved, the sprocket moved. And
yeah, you can actually, if you want to spend a lot, McMaster Car, which is an industrial place that basically sells everything, and not everything is very cheap there, but you can buy pretty much everything there. Not FRC specific stuff, but if you need metal, all sorts of weird things. But they sell little, like $40 a piece, which doesn't make sense. But they were basically plastic sprockets with the inside taken out. They'll actually give a little bit, so when you put them inside two chains, they actually push out and they tension.
We use those this year.
Yeah, they work.
$60 a piece.
Yeah, they're ridiculously expensive. I've never bought one.
Well, they work well. We shredded one eventually.
Yeah, but
actually, if you found one on the field, it was
they work fine. And the advantage of it is we had no room for anything fancy for tensioning. All we had left was something inside the chain, which is why we use those. But external tensioners work fine.
Yeah, you can do all sorts of different external things. You can have small pieces of plastic that push down your cam or all sorts of things.
Because we were having the same problem, but we used the Vex Pro, basically box for a lot. But we found it online, and I have kind of a picture of it here, as I was looking for. It's basically, but you have to somebody to machine it for you. It's made out of plastic. Okay, it's Delbrin, and basically it's just a circle, about that wide. You have a groove for your chain. The side of it, instead of having a center hole, you have holes at different sizes, like different spots. You put it between your chain, you pick one of the holes, and basically you turn the wheel up. So it's you can tighten it at any time. All you do is loosen the bolt just a tiny bit, tighten it where you want it, tighten it back up, and you're good to go. Very, very fast. And if you realize your chain is stretching out a little bit, we honestly, when we're in a quick fix, we'll take the bolt out, move it to a different hole, push it up a little more until we have time to do what we need to do. I have a slide picture of it here if you want to see it.
And for chain tension as well, the number 25, it matters a lot more to get chain tension right, because you can skip the chain off of your sprocket really easily. The groove into the chain is much smaller. 25 chain is just tiny in general. 35 chain, it's much more forgiving. If you're going to do something with chain and you don't know what you're doing, stick with 35 chain. Or if you just don't feel like doing it, if you don't feel like putting a lot of work and effort into calculating and getting all right and tension right, use 35 chain. I have a feeling we won't have 25 chain on our robot for a very, very long time, just because of how reliable 35 is. Like you can literally there's chain calculators where you can figure out if I have this sprocket size, what is the right size for it to be on 35. You can calculate that size, stretch the chain to it, and let it run for close to a whole season or a regional and never have a problem without a tensioner at all. And that's what we've done with 35. You can pull it crazy tight. They make little chain puller things that you can pull chain. It's steel. It doesn't break very often. One of the issues with chain is that it's steel and heavy. So long runs of 35 get really, really heavy. But it is.
We use 25.
Yeah, and if you do everything right and you tension it right, 25 is a lot easier. You save a lot of weight. But for things that you don't want to do everything right and you have the weight for, you can throw 35 at a problem and it won't break. Like it's almost impossible. You can shear 30. You can snap 25 chain if you put it under too much torque load. pretty hard to do that with 35. I don't think I've ever seen it in FRC, but somebody's probably done it.
I should have brought 35 chain.
I actually have some in my car.
I have a ton of chain. We just have to. It's actually where'd the bins go? Oh, they're like sitting right in front of Jim. Actually, Jim, if you want to open those boxes, they're labeled chain. There's tons of chain.
So some of the teams talked about they want free stuff, and so chain would be
Yeah,
35 chain would be
we had
something.
bits of chain that
I would
people can
have
take
plenty
and
of
they can.
here, because we don't use it.
Yeah, if you want it, yeah, please grab.
25 chain. It's almost bicycle-like.
It's dainty.
Yeah, there's 25. I think 35's in the other bin. Yeah, if people want to go and pass it around, feel free.
If the racer is one, you're 35 chain for your wheels.
The kit of parts was chain.
The kit of parts was chain for a long time. The kit of parts was always 35 chain. The kit of parts was never 25. Okay, belts we've talked.
Just for fun, a few years ago, for prototyping, we bought number 80 chain. Like 3 links of it, just for a particular use, and it was ridiculously hard. We never used it, but it was fun to like, this is like chain.
Yeah, bicycle chain is somewhere in the 40s. I don't remember exactly what number it is. I don't even know if it's an exact number, but it's roughly 40 something.
If you work with chain, make sure that your master links are the right side for the chain.
Right.
So if you're writing 35 chain, you really have to buy 35 master links, not 25s. Because if you're at crunch time and you realize these don't go together, you're kind of hosed.
Yeah, I mean, that's yes, the master link and half link stuff. Like, there's a lot of chain details. We're going over this quickly. You can go on Cheap Delphi, you can go on other places. There's presentations that have just very very detailed stuff like that. Feel free to ask questions. We can answer all of those type of things. But they are pretty detailed. Don't cut chain with a hacksaw. There are a certain tool called the chain brake that actually pushes the pin out. That was one of the things I had to fix when I got to this school. I went through all the chain. I was like, wow, are these what? They had all been cut with a hacksaw instead of actually like disassembled like they were supposed to be. So yeah, things like that are bad. But please read manuals or ask questions on how to use stuff if you're not sure. Belts are nice, but belts can't be resized. So you have to get belts to the right distance apart, or have some way to tension it really, really well. Because you can't stretch. You can't say, oh, I want to move this in slightly, and then take out a link of chain link, or take out a link of the belt link. You can't change. Belts are a lot quieter.
We blew at least 3 belts over the course of the season.
So we didn't break any until after the season. We went through champs without any belt breaking, and then we broke several at Conapalooza thing, then we broke one at TRI, I think we broke one at Reboot. Once they start wearing, they were all going. But
We shredded a belt at San Antonio. It came out of the robot fibers.
Yeah. There was one at TRI, we left one on the field at TRI.
So there are a bunch of advanced gears, but at the same time, I'm not going to go through all of them. However, this one I do want to go through. Planetary gearboxes for a long time were difficult to do, but Vex Pro just 2 years ago released what are called the Versaplanetaries, and they make planetary gearboxes really easy, and they're about as awesome as you can get in terms of building mechanism gearboxes. Of course, this is a long side thing. Give me 1 second.
It's really nice to have a set for prototyping, because the Versaplanetaries, you can stack different ratios together, so you can kind of customize whatever you want for a certain situation and test it out. But if you were going to have a bunch, the individual gear stages are kind of pricey.
The advantage of this particular model is you can have a hex output, a half-inch round output, or a sieve output. And so when I bought our set, I bought pairs of each output style plus a bunch of gears, so you can mix and match whatever you're gonna need.
We have these on our intake system. That robot will be up here a little bit later this morning, and they're on the intake for bringing the ball in. They're also down at the bottom for controlling the position of the intake bar. And we have the little, I don't know what you call these, the pins here. There's a special name for them, but the pins that are in the gears, those keep working loose. So when they do, that means that it binds.
Yeah, that's a torque issue a little bit.
We found that if you super glue those in, that actually holds.
That's what, I told the kids, I said, you know, let's, cause they had them all greased up, I said, take them apart, let's, Loctite the pins in place. We used press fit Loctite, fit them in place. We have just done that recently, so we don't know what that's gonna do to the amount of cycles that we run.
Right. Grease. Gearboxes need grease. Please put grease in your gearboxes. Don't run them dry.
Otherwise, you'll be making metal powder, kind of like talcum powder.
Don't overgrease, though. It reduces efficiency.
Overgreasing is a much less of a problem in FRC than undergreasing. You can.
All right, this past year, Jim probably can talk better than I can, but we overgreased our first planetary gears, and then we got air pockets in them, and caused our gears to get all gumped up.
We had theories of that. I'm not convinced that it was air pockets, but we had some on the team that thought it was, and it may have been. I just don't know.
So
we did find that to clean them, when we would take them apart and clean them, that a helpful tip for cleaning a lot of things is brake cleaner.
Yeah.
So we probably bought 20 cans of brake cleaner just to clean off the grease, and then the gears are brand new again. Then you can inspect them, see if they need repaired.
Make sure your kids are wearing gloves.
Do that outside.
Yeah. So
we have a fume hood.
It does. There's nastiness, but it cleans the grease really well. And
Yeah,
you get the parts
fume hood's
brand new.
fine. I use it for my guns. They're great. But I do it outside.
That sun gear is where one of those gears that are press fit that you were talking about earlier. And when you strip it, when you have a sun gear come loose from the shaft, it takes a hard time to troubleshoot that gearbox because it was run under no load.
So one of the huge advantages to this gearbox, the Versa Planetary, which they actually increased price again. Last season they were really cheap. They went up this year a little bit, but they're still really versatile because this backside is designed to take a huge number of motor inputs. So of the list of all the motor inputs you can use, basically everything but a sim can fit in here, and actually a sim can if you do it right. But it requires like cutting things and it's a little weird. But all of like the other motors that we use on all of the applications can all go in here just by changing out that little collar and how you tighten it down. So you don't have to worry about press fitting things onto your motors. Swapping a motor is a 2-minute task compared to a 20-minute task like it used to be for other gearboxes. Like we've done it between elimination matches before, and that's one of the things you always want to be able to do on a robot.
Except for the element, which is a very weird size.
It's not a weird size, it's just a bad set screw. It's a standard size, it just strips out to where you have to use a metric one to do it. So if you were, we buy steel set screws that are higher quality from McMaster and swap them all out, and it works fine. That's one of the things, I don't know if they started, they were planning to change the set screw. I don't know if they're shipping the new one or not, but at some point they'll be shipping a new set screw with them.
So what were they doing with the set screws? Or?
It was low quality and it would strip to where the standard size wouldn't be in there anymore and you had to use a metric. But that's...
Yeah, we found that with in Vex with the new wheel collars, that some of those wheel collars for the Vex kids, you tighten them up and it like crumbles in the collar.
Alright, so we can pass that guy around too. There are little parts and there's some grease, so it's not deadly or anything. But yeah, normally whenever we're playing with gearbox stuff, we just get a scrap piece of plywood, set it on one of the tables, and lots of paper towels. Kids most of the time enjoy getting grease all over their hands, so we don't love for most of that.
The found with Vex Pros this past season is we were very positive where we're overusing. We had as much as a 500 going ratio, we had gears stacked up, so we were really going crazy on the gear ratio. But the most common thing that we ended up swapping out was the black aluminum square outer.
You were breaking the outer square?
There was cogs getting broken off of that. So once we figured that out, we kind of get good at swapping those out. But it was not breaking the inner gears very often.
Yeah, we've never broken the ring gear, but we also, there's Vex Pro releases a little chart that says if you're using, if you have this ratio, what happens, blah, 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 all that. And if you follow that, they have like green and yellow and whether it's recommended or not, and what the torque load is going to be. And you can look all of that up and find out exactly what it's going to be. But that makes designing mechanisms so much easier than in the past. Like there were, BaneBot sells planetary gearboxes too, but each one of those you have to buy the same. Like if you want a 1:24 ratio, you have to buy that one. If you want the 1:64, you have to buy that one. These ones you can literally stack different gears and do all sorts of really creative things. They work really well for prototyping. You get the 1/2-inch hex output shaft. You can throw a hex sprocket or something on it, and you can have a mechanism up and running in a couple of minutes.
And the other thing with the BaneBot ones was you had to buy it for a certain motor.
Correct.
You couldn't, like the Versa Planetaries, let you do almost every motor.
Yeah, basically every motor will go into that. Any motor you would need to use, basically. But yeah, you can stack to get a lot of reduction on a single motor if you're not going to put a ton of load on it. Like you were saying, he was doing 500 to 1, which is a just massive reduction.
But the rig gear is aluminum, if I remember right, and the others were metal, so the aluminum was really the weak point.
Right. Yeah, but it depends on. So a lot of times that is. The other place is the spline on the actual output shaft is what was breaking before a lot of it, 'cause that's also aluminum. Most of the Vex Pro aluminum, which is nice, is that so in terms of the politics of FRC slightly, most Andy Mark parts are American made, most Vex Pro parts are imported. So if you for some reason have a preference, you can go that way. We use whatever works best on the field, and whatever we can do for cost a lot of the times too. Also Vex is nice because it ships out of Greenville, so to most places in Texas, even regular shipping is 2 days, or 1 day on occasion. I'll order things Monday morning and get it Tuesday, so on regular shipping.
It's also true of an electronics company we use called Mouser.
Yeah.
They're in Mansfield, and you order stuff from them, and if it's like before 3:30, you'll probably get it the next afternoon.
Yeah, there's a lot of ordering in Texas helps a lot for those types of things.
And McMaster is surprisingly fast for most stuff.
Yeah, if it ships out of Georgia, it's very fast. If it ships out of Chicago. Okay, drivetrain questions, or I'm going to be finished because that was a lot of mechanical stuff. Anything?
How do you choose the drivetrain for the strategy? What's your thought process?
The drivetrain for the Saturn. So
I know
right.
the math.
So in general, it's 6 or 8 wheel, unless there's a reason to not do it. The reason to not do it this year was in that drivetrain, same reason that Scott and them tried to do it, was we thought driving sideways would be important. We were wrong. So then we stopped. But then at that point, we were so into that drivetrain, we had to do something to make it work, and going to a 6-wheel would have been much harder than going to something like that.
And that was the reason why, I don't know why you guys thought sideways was important. We thought sideways was important for catching.
Yeah, same thing.
Was the thinking at the time.
And it was an entirely flat field, and that was like a nice hanging fruit that first gave us. Because they haven't given us an entirely actually flat field with no obstacle. Yeah, I guess 2013 was that way too.
By doing the butterfly, or what do we call it? Tex Coast?
Tex Coast.
Tex Coast.
So Tex Coast is a pun on West Coast. That is entirely a joke between us and 148 on Twitter that I kept propagating, and people got mad at me for.
So on the Tex Coast drive, we knew we'd be able to fit in the Omni Wheels instead. So it'd be a really easy change, and we thought about whether we'd be happy with that or not. And one of the problems that we've had in the past that we were trying to get away from is that when we would get T-boned by a defender, we would just get stuck, and they'd push on us, and we'd basically just spin while they were pushing.
So that's called a friction pin, which there are no rules that make it complete. It's completely legal to do, and you can hold somebody to where they can't do anything for large portions of the match. 3310 literally changed their robot because we played them 5 times at Dallas and basically friction pinned them the whole match.
So that's why we went with the Omni Wheels. When somebody T-bones us, then the idea is we just can bounce off of them. But then Robert, our driver, he worked on a technique, so he'd be driving along, and then once that robot was coming into T-bone us, he just was able to spin the robot and just spin them right off, just spin our robot right off their bumpers.
And having a lot of it is what you have experience doing. If you're going to build anything that's not a 6-wheel tank drive, it is much better to prototype it in the off season, in the fall, get something running and driving. We did it this year because, one, we foolishly thought, oh, this game looks simple, we can spend some time on Drivetrain, the rest of it will be easy. That was silly. But doing it in season is much, much harder. You only have 6 weeks. If you fail, that failure costs your team a lot more, so you have to get it right. But yeah, I really like that drivetrain. We'll probably use that again if we have a flat field, but if there's obstacles, things change a thing. The other reason that's nice is it takes less battery to turn because you have no scrub. So if you build a really, really efficient six-wheel drive, it probably is the same way. So like Cheesy Poo's drivetrain takes very little battery to turn because it's really efficient. Everything, the weight balance and everything is good. They were really light, so they had less scrub as well.
If you asked me what our drivetrain would be next year, I would tell you that it's probably going to be 6 or 8 wheel until we see the problem.
Yeah.
And then when we see the problem, we might prevent that. But we haven't done the swerve or unicorn type drive yet, and we won't do that in season. We would only do that in off season.
And you would use Omni Wheels?
Omni Wheels for the
six
No.
for
probably not.
No, just all traction, and then just make sure your tip is right. And
Yeah, the tipping point's right. You can turn just fine on that.
yeah, like they did their 2013 robot did that really, really well. I mean, they could be driving in a straight direction and pivot completely backwards while moving. It was pretty unnoticeable. They had a really good driver too. That helps.
Yeah, you gotta be careful. We were down at NASA driving one of their
Backbots.
You know, I can't remember which bot it was, but it was the wide short, and they are really squirrely to drive because the distance between your axles is so short relative to the width between the wheels.
Well, so that a lot of that is depending on code as well. So these drivetrains that are all Omni are ridiculously swirly if you don't do something in code to make sure you're kind of going straight, because you have no friction preventing you from turning left or right. So you can throw the back end out of these things extremely easily if you have nothing there preventing you to do it, because you literally have no traction. So you can oversteer or understeer all you want depending on how your driver's actually doing the inputs. There's the other part of drivetrain, just like the other part of everything in the robot, is how you program it. You can do really simple stuff where you have like one joystick powers the left side, the other joystick powers the right side, which most people hold tank drive or something along those lines.
It's called tank drive.
Yeah, there's other things, but call it tank drive. That's a little. You can do it. You can get in theory, you can get every input you'd ever want to the motors. You have to have an extremely good driver to do it and actually drive straight, because if you're going this speed and this one slightly this way, now you're turning that way. So there's many other ways to do it. Oh, absolutely, but you have to have really, really trained drivers. A lot of teams are moving to some version of a Halo type drive where they're shifting it onto gamepads. This one controls forward, backwards, the other one controls turning, something along those lines. There's fancy algorithms. We use something called Cheesy Drive, which actually, or a variation of Cheesy Drive, which means this stick actually controls turning radius only, so if you just turn it left or right, it doesn't actually do anything. So this is like your steering wheel, and this is your throttle.
But he's right, there are some drivetrain configurations that are inherently more difficult or less difficult to drive. In 2002, our first year of doing early, I was coaching a team up in Houston, Super Houston, and we had our students build various different, really wide but short robots, or really long but narrow robots, and just had them drive them with the early Lego stuff. So it was very rudimentary compared to FRC, but you can get some, with the same driver skill, some ridiculously different results depending on the shape of your robot. One that's really wide is inherently going to turn a little bit slower and easier to control. One that's narrower is going to be very twitchy. So it's something to keep in mind. Geometry can affect that.
Yeah.
So the only thing I'll say nice about like the Mecanum wheels is the kids would love building with them once, having them on the robot and playing with the code and seeing how the robot moves. So it's kind of a cool, I'd say, a cool off-season project. And honestly, with good wheels, it'd be okay to use them in season. But
yes and no. So if you use them, be worried that you're immediately lower on most people's pick lists. Like pretty much instantaneously, by making the choice to use Mecanum wheels, your draft stock goes down.
Draft stock with teams that like us,
right?
38, 47.
We have, but it's not. It doesn't mean we're not going to pick you. For other people, it may mean you're not going to pick you. We have drafted people with Mecanum wheels, but the same robot that had tank drive would go above them because of reliability, because of pushing, because of how elimination matches normally play, where there's a lot more physical game. And if it breaks, We can repair it easily. We can give them a spare wheel. Normally, it's harder to give them a spare mechanism wheel if we don't have them. There was also a cost associated with it for a long time. Until Vex Pro came out with mechanism wheels, a set of Andy Mark 6-inch wheels was in the $450 range for 4. Nowadays, you can get the Vex Pro ones down to the $200 range, but still way more than the $5 it costs for a Versa wheel. So
It's also the cost of the 2 additional gearboxes.
Correct.
And the more motors, the whole 9 yards. You put the whole thing together, you're looking at a $1,400 frame.
Right. In general, it's way more expensive for an extremely small amount of performance gain and many times a performance loss.
I guess the best way to do that would be buy a Vex robotic system and get their mechanism wheels.
Yeah,
and play with those.
Are there FTC mechanism wheels? I don't really know. Do you know there are FTC ones? Okay. Yeah, no, I was just
buy
wondering.
FTC.
I mean, no, buy Vex or FTC. I don't care. Yeah, we're not. Yeah, this is.
I've gotten that senior motor spot. I could have said.
No, there are definitely both, right? Yeah, you can definitely get them either way. Even the Vex set is like $100 though. They're not cheap.
Yeah, but they're so much more affordable than the Andy Mark.
No, I'm talking about the Vex. Like the Vex, just the normal small 18-inch Vex robot. The mechanism wheels are still kind of expensive. Okay, so if we're done with that.
One last question on
Yes.
wheels. What are your experiences with different types of wheels? Not Omni wheels or just traction wheels.
Good question. Okay, so before Vex Pro really came out, everybody for the most part was using conveyor belt tread was the standard. Wheels.
We call it waffle tread or
rough top or wedge top or something along those lines. So that, do I have a picture of tread? Let's see. So that's kind of what the tread looks like. And you basically wrap that around a wheel. There are many different wheels that could take it. You rivet it, or these little like alligator clips that are actually designed to hold the tread on, that kind of stuff.
Yeah,
there's a system with zip ties now.
Don't the new Versa hubs make it like, or something, they have a wheel that makes it really easy to.
Yeah,
Look at the performance wheels. They're snap and change.
Yeah, the performance wheels have the little like zip tie thing now.
Nice for the one developed with zip tie mount.
Yeah.
Also adopted.
Right, that's the one that Andy Mark sells. So, but these guys are the new Versa wheels that started coming out the last season or so from Vex. Andy Mark has a version of the kit wheel that's similar that also costs like $6. And these will get you all you basically need for an extremely cheap cost. And when you're talking about, it's probably much easier to just buy something like this or the Andy Mark version and swap them every event than it is to worry about swapping tread. The wheel costs for the ones that swap tread are normally more expensive. Basic stuff, it's much easier to go to something like this or
we swap
Andy Mark
on
wheels.
On this frame, this robot, we constantly swap the tread out. It's just part of having wheels. So he liked the front wheels to be bald.
These guys.
We didn't have to swap those out very often.
Yeah, so these are the Andy Mark ones. They're $6 a piece. You can get them at different times. Coulson's are another one, but you do have to buy the hubs for them. You used to have to make the hubs. Luckily now you don't have to, and Vex sells the hubs. And Team 221 Systems is another smaller distributor that sells them too. And these are actually, Coulson wheels are industrial caster wheels that have a really tons of work went into making that rubber awesome. So they work on like nearly any surface. They're great for demos on like concrete because they don't really care. They don't really get eaten up. They work really well on the carpet too. They work on pretty much everything. The Coulsons are really awesome, but they're slightly more expensive.
They're $6.
When you add the hub to them, each wheel's 20.
Right.
But so yeah, we've run Coulsons before on the center set in 2012, and that works well. You can play with different wheels on different parts of the robot. So if you have a 6 or 8 wheel, and you know that 4 of your wheels are going to be on the ground most of the time, you can have different wheels on those 4 than you have on the other ones. Some teams will do 8 wheel where they have the 4 standard wheels and they have Omni Wheels on the outside. Titanium, who's an awesome team, 1986 out of Lee Summit, Missouri. They build that drivetrain every year that people find silly sometimes, but they win lots of events. They have the second longest regional winning streak besides 2056. 2056 has never lost a regional. They're ridiculous. I don't even know what it's at now, 25 or 26 or I don't even know. It's a crazy high number. They're out of Canada. Okay, so with that, if there's no more drivetrain questions, I think we covered a pretty wide scope of that.
Mike, did you have a question, or did we?
I was just gonna say, when I say VEX, I just cover.
Oh.
When I yeah, like there's, it really, the VEX FTC thing, let's hit on that very, very quickly for teams who don't know. They are competitors, obviously. There is room for both of them, no matter what some people will say. We are not in anywhere near enough schools. If both programs did really well, we still wouldn't be in every school. In Houston, there are far more VEX teams than there are FTC teams, but there are still a lot of FTC teams. Gators Elite, you guys did FTC for a long time, right?
We had FX team this year.
Right. Oh, yeah. Yeah. So they do both. So depending on what you can do, both systems work. Both are getting upgraded. I'm a big VEX guy. I've been head ref at VEX Worlds before, and I run a lot of the Houston VEX tournaments. But there's no difference with FTC. I actually got turned off from FTC because First made us use their motors in 2011, and I hated it.
That was a very strict year where they kind of highly encouraged you to have an FTC team for the minibot.
Yeah, and then that was why I never do FTC, because I hated those motors so much. It was a really bad idea on First part.
They were the motors that we had to use burn out all the time.
Yep.
And it's just kind of dirty marketing. It's like you
well,
shall have an FTC set of components to use it to build a minibot.
In the back room politics of FRC, that was when Woody Flowers and Dave Lavery quit the GDC. So there's that. But things are turning around. First headquarters is awesome. Frank is cool. Everything's peachy dory in my mind right now. Okay, do we want to do Greg show off new fancy stuff time?
Yes.
I think that was a good plan.
Break before we do?
Okay, we can have a break, but let's make it an actual quick break this time.
Quick break.
As in, like, we're starting at 10:10, so be back.
I didn't hear about that. That was the minibot thing the reason why Dave Lavery and Woody Flowers left the GDC, or was that in response to?
There was a team update that said, by supporting FRC, you are supporting FRC program, you're supporting the other First programs and their kits. And their kits bit is what I believe made them leave. Because we basically said, you're saying I can't be mad that your motors suck. This is ridiculous that run out.
Well,
yeah, cause I knew he was on the GDC since the dawn of the GDC, basically.
Was until 2011.
What's the? So I know this is the shifter here. What actually makes that shift?